Welcome back to the channel. Today we're going to talk about the ground effect in airplanes. And I'm going to show you what happens when we fly really close to the ground. Let's go. When an aircraft operates close to the ground, the presence of the surface alters the way the airflow goes around the wing. In normal flight, the wingtip generates vortices due to the high pressure air below the wing trying to move toward the low pressure air above the wing. These vortices create induced drag, which is a byproduct of the lift generation. In the ground effect zone, the proximity to the ground disrupts the vortices, reducing their intensity, and with weaker vortices, the induced drag decreases, allowing the aircraft to maintain speed with less engine thrust. The ground also changes the pressure distribution around the wing. The airflow over the wing becomes more efficient, generating more lift. In fact, when we fly close to the ground, the portion of the induced drag is lower, so we basically have a little bit more lift. So the airflow over the wing becomes more efficient. And this kind of increased lift means that the aircraft can sustain flight at slightly lower speeds, creating the sensation of floating near the ground. So basically, at the end, it's like having a little bit more of lift and a little bit less of drag. Now let's talk about the ground effect during takeoff and landing. During takeoff, the ground effect can make an aircraft seems to lift off the runway with ease, but this can create challenges like a premature takeoff, for example. If the aircraft leaves the ground at a speed below the recommended climb speed, it may lose lift as it exits the ground effect zone, and this can lead to unstable climb, higher drag, and increased risk of stalling. During landing, on the other hand, the ground effect slows the aircraft descent rate. It's like floating above the runway. The increased lift and the reduced drag can make the aircraft feel like it's gliding along the runway rather than descending. But if it's not managed properly, this floating effect can delay the touchdown and can cause the aircraft to overshoot the intended landing point. So for pilots, the ground effect is really fundamental because they must take into account this kind of effect during the two phases of takeoff and landing, of course. If we look at the equation of the induced drag, we have lift over pi E, which is the Oswald coefficient, B, density and the velocity. E is the Oswald efficiency factor, and it goes up a little bit during the ground effect. Why? Do you remember on one of my past videos when I was talking about the lift distribution over a wing? Well, the Oswald coefficient is just telling us how efficient is the wing based on how the lift is distributed over the span of the wing itself. So basically, when we get closer to one, like the Spitfire wing, for example, we have a really efficient wing. So if we talk about fluid dynamics and what is happening during a takeoff or a landing, we have a disruption of the wingtip vortices, as we said before, and the lift distribution over the wing changes. And that means, in another word, that basically our equation is changed a little bit. Our Oswald coefficient goes a little bit higher, and that helps to reduce the induced drag. So even if the ground effect helps us reduce the induced drag, still we have a little bit of limitation. Let me show you. First, we have an altitude dependency. So the ground effect only occurs at altitudes lower than the wingspan of the aircraft. Beyond this range, we just have normal aerodynamic forces that dominate. So basically we have the ground effect and the wingspan. If we go lower than the wingspan and h is higher than w, we can feel the ground effects. And the graph is something like this, where we have the distance to the ground and the ground effect. So the higher the ground effect, the lower the distance to the ground, and the far we go from the ground, the less the ground effects. Another thing we have to take into account, this is for pilots, of course, they must be trained to recognize and compensate for the changes in lift and drag to avoid premature takeoff or overshooting during the landing. So, to sum up, the ground effect help us reduce the induced drag, but still we have a little bit of challenges related to the pilots that they have to remember when taking off or landing. I hope you like this video, and I'll see you on the next one.